Okay, so today we're going to look at graphing the other four trig functions: the secant, cosecant, tangent, and cotangent. And so I'm going to use this screen right here to kind of show you how it's kind of developed. I'm going to be looking at graphing the secant graph, and so you're going to see it cycle through, and so just kind of watch as I move across the angles. As the angles move, you can see little dots are forming. Sorry if the color's hard to see. So we're doing those, and then as it does that, then it jumps down, and it comes down below. See it down below? So it's creating these little humps like this. And because the secant is related to the cosecant, I want to show you that relationship. So if I click on this, you'll see the cosine graph. And what you'll notice is that you have these series of U-shaped things that occur. This is the other half of this one. And this U-shape down here, okay, occur at the peaks and the valleys of the cosine curve. So these are U-shapes, but see, we also have this gap where there's nothing in between. And what's going to happen there is we're going to have vertical asymptotes. And that's what all of these graphs have in common. All of these graphs are graphed at this time because they all have vertical asymptotes. Okay, so I'm going to show you all these graphs so that you can see how they're done. Okay, so we'll do one at a time here. So here's the one I just did. I'll show you all the characteristics of it. Focus a little bit here. Okay, so all of these functions have this. So here's the layout. This is what you saw before. You saw this graph, this piece right here, this piece, and this piece right here. Secant graph, like I said, is equivalent to 1 over the cosine. If you remember when we did our work from before, to find the secant, we just did the reciprocal of the cosine, so that's what that comes from. Okay, here's our here's the 5 main points, our 4 corners on the unit circle, and we go around and we determine, plugging them into this right here, you see that we have 2 undefineds at the pi over 2s and 3 pi over 2. That's where the vertical asymptote is going to occur. Now, these graphs continue on forever. So that means that there is an infinite number of vertical asymptotes. So we want to be able to express all of them in one complete expression. Okay? And so this is how you would do it. So what is the first one that is non-negative? So the first non-negative vertical asymptote, in this case it would be pi over 2. And then where is the next one? Well, if you look at it, the next one is a distance of pi away. Okay? If I go backwards, that's the distance of pi. So they're all pi apart. And so to express that in a generic fashion, it's the first one and then plus or minus some multiple. That's what n means. It's a multiple of pi. So when n is 0, that's not there. It's just pi over 2. When n is 1, then I'm going to take pi over 2 plus pi. That gives me that one. Or pi over 2 minus pi. And that will give me that one. So that's what this notation means right here. We're going to use it quite extensively for the rest of this unit because of these vertical asymptotes. So the domain is all the real numbers except for those. And you need to have the counter also. And the range, if you'll notice, remember for the cosine, the range was all the numbers between -1 and 1. So the range here is all the y values outside -1. So below -1 and above +1. So remember that the secant graphs go away from each other. They go outwards. Okay? So that's the secant graph. The cosecant graph is very similar because it is related to 1 over the sine. And so using the same process here, you'll see the same thing. You have a vertical asymptote at 0 and at pi and at 2 pi. And you have the U shapes again. So the first non-negative vertical vertical asymptote is at 0. And so then this would be written as 0 plus or minus n pi. And I should put plus or minus here. Excuse me, I forgot that. Plus or minus n pi. But we don't need to write the 0 in front. So it's just x cannot equal plus or minus n pi. And n is the counter. And that gives me all of those forever. And the range is the same as the one before. So the secant and the cosecant, because they are reciprocal functions, look very similar. They're just shifted over from each other. Just like the sine and cosine were. And again, if I do the drawing in between here, it'll be the sine curve in between. So let's look at the tangent. The tangent and the cotangent are different also. They're similar to each other, but they are different. They are ratio functions. This one is the sine divided by the cosine. Remember, because sine is associated with y and cosine is associated with x. And so then the definition of this is y over x. That's kind of why that works out. So whenever the bottom is 0, we have vertical asymptote. So whenever the cosine is 0, then we're going to have a vertical asymptote, which means it's going to have the same one as the secant. So you have cosines on the bottom. So there is the vertical asymptotes. So the tangent has the same ones. Okay? And these graphs look like that. Okay? And this is the bottom half, this is the top half. This is kind of separated, so it's in the same window, in a standard window. Okay? The range is all the real numbers work. And the cotangent is very similar. It just goes in the opposite direction like that. And because this is the cosine divided by the sine. Its vertical asymptotes are going to be the same as the cosecant. One is at 0, the next one is at pi, and 2 pi, and 3 pi, and so forth. Okay? And again, I forgot the plus or minus there. So those are your 4 trig functions. They're graphs. And we want to be able to graph all forms of these, just like we did in the other one. And the process for graphing these is exactly the same, or almost exactly the same as for the sine and the cosine. These graphs, though, you'll notice I did not talk about amplitude. None of these graphs have an amplitude reference. They have, in addition, in its place, you're going to have to identify the vertical asymptotes. Okay, so no amplitude for any of these 4. Only sine and cosine have the amplitude identifier, and these all have a vertical asymptote that you're going to have to find. So with that, let's go graph some generic and talk about how to solve these things. So I have some already done. Let me change things around. We're going to graph a couple of these things, but I want to walk through the steps that we're going to follow. How do I graph these? Well, just like before, whatever's in the parentheses, we're going to set it equal to 0. We're going to solve that. That's the first number in our table, and it is also our phase shift. Okay? For the secant and the cosecant, it has a period of 2 pi, where the tangent and the cotangent have a period of pi. So then the next number in our parent table is a little bit different. The first number is still equal to 0, but the second one for the secant and the cosecant is going to be, you take it set it equal to 1 to pi over 2. And for tangent and cotangent, you set it equal to pi over 4, because that's the second number in the parent table. And then we do the difference between them to find the spacing in between each and all the rest of the tables. Complete your table. We're going to draw from the table, you'll have undefined. So draw the vertical asymptotes in your graph first, and then draw the curves in between. You have to draw at least 2 complete periods. Make sure you identify the period, the phase shift if it has one, and the vertical asymptotes in general form. That's what the plus or minus n pi thing. And you need to make sure that you have the general form. Don't just list the ones you see, you have to list all of them. Okay? And I already said this right here. Note that these functions do not have an amplitude. So with that, let's go look at some of these problems and see how we're going to go through it and what's going to be asked of you. So I have a couple already set up over here. We're going to do the first one is a tangent curve. And we need to go through this process and graphing on here. All right? So We also want to list the transformations. Okay, this is also something you're going to be asked to do on a regular basis. So, what are the transformations in this curve? So remember, even though you don't see it, the parentheses are right here around the x, around what's called the argument. So there's nothing in there, so there is no horizontal transformations. The number out in front is a, that you're multiplying by. So a is 1/2, which means we have a vertical shrink by 1/2. And then this number right here is being added to this term, so that means it's up 1. And so that right there would have determined if we had any reflections on the x-axis. So there's my two transformations for this curve. The period for tangent and cotangent is found by pi over b. This is why I always write this down so I don't forget. Pi over b is the period formula that you use for tangent and cotangent only. B is the number in front of the x. There is no number in front of the x, so that means this is simply going to be pi. So we have a period of pi. There is no phase shift because, again, there is no horizontal transformations. And then we want to write down the vertical asymptotes. I recommend that you wait and do that absolutely last, because then you can double check and make sure you have the right ones in here. Especially if there's any kind of transformations in a horizontal sense, the vertical asymptotes are going to change also. So I would wait and do those last. Okay, so according to what we said to do, take everything in the parentheses, which in this case is just x, set it equal to 0. That is the first number in your table. Then you take the stuff in the parentheses, which again is x, and you set it equal for tangent to pi over 4. Okay, so again, let me just show you real quick just to reiterate what I was saying. Remember, for the parent table for a tangent, it's 0, pi over 4, pi over 2, 3 pi over 4, and pi. Because the period for a tangent and cotangent is pi, whereas the other ones is 2 pi. That's why we have the numbers we have. Okay, so now we're here. So I know this is pi over 4. And so there's no transformations in the horizontal sense, so x is going to be exactly the same as the parent table. And so I know this is going to be pi over 2. This will be 3 pi over 4. And this over here will be pi. Okay? So based off of that, it's the distance of pi. I know this right here is going to be pi over 4, pi over 2, 3 pi over 4, and pi. And this is the negative of those same things. Negative pi over 2, pi over 4, and negative pi. That's how the scale is set. Okay? So based off of this, okay, we can now finish our table. Remember that the tangent is, and sometimes you might want to write it, this is the sine over the cosine. So when I plug in 0, the sine is 0, but the cosine is 1, so this will be 0. So the tangent is 0 at 0. So it's plus 1, means it's 1. At pi over 4, when you plug it in, this right here, the tangent at pi over 4 is 1. Times a half is 1/2. So 1 plus a half is 1 1/2, or 3 over 2. At pi over 2, when I plug it in, the cosine is 0, and since the cosine's on the bottom, it's undefined. And once I have an undefined, the whole thing is undefined, and you just put a u. 3 pi over 4, plugged into here, the tangent of which is going to be negative 1. So a negative 1 times a half is negative a half. So 1 minus 1/2 is 1/2. Okay. Again, this one is back to where we started. So if I plug in pi, this will be 0. So then we have a 1. So there's my table. I would start by plugging in and drawing in my vertical asymptotes. I have a vertical asymptote at pi over 2. So at pi over 2, we draw a dotted line right through pi over 2. Okay? Put in our scale this way. I got to go all by halves. So if I do this right here is 1, this right here is 2, this right here would be -1. Then I can do the rest of this. So at 0, I'm at 1. At pi over 4, I'm going to be at 1.5, which would be right there. There's my undefined. This one is going to be 1/2, which is right here. And then back to 1. Now, if you remember what it looked like, literally what I'm doing is I'm drawing that piece right there. You see? There's that one piece over there and that piece right there. And so if I continue this and put it over to here, I get that. So this is how you extend it back the other direction. Okay? This one is from 1 down here and going this way. So that means this point right here is going to be at 1/2. Okay? If I look at my things here, I can see that because it's exactly the same kind of table, that all the vertical asymptotes are pi apart. So where's pi going backwards? Pi from here would end up here. That's 1/2. That's another 1/2. So this is another vertical asymptote. When you do in tangents, you'll see 3 dots in a row. Cotangents will go probably this way unless there's reflections. Once I have the 3 dots in a row, then I know how this is going to lay out. It's going to come from down here. Once I have the 3 dots, I just got to come down like this, go through the 3 dots, and go up that way. Draw an arrow. This is just the bottom half of one. And then this side over here would be the top half. So dot, 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 and then dot, dot, dot. So there's no dot here. So this one's going to be at the high one. Let's make sure I'm at 3 halves. And then this one's going to be at 1. And so this would be the top half of that. See? Follow that like that, like that. So that's how you would draw one period this way. If you wanted to and just start here and go that way, you can. That's up to you, however you want to draw it. But this is how it's laid out like this. Okay? So with that, I can then come back and look at where's my vertical asymptotes. Well, the first one that's not 0 is pi over 2. So vertical asymptotes are when x equals. Vertical asymptotes are listed as x equals pi over 2, plus or minus. And then the next one is how far apart? Pi. So that means n pi. And then n is the counter. So that's the vertical asymptotes. If I was going to list the domain, it would be all the real numbers. X cannot equal those. Okay, but I'm just listing what they are. This graph is complete. Again, your grade is going to be the basic shape, that you have the right shape in the right spot. The vertical asymptotes are drawn as dotted lines, and you have the proper scaling. You don't need to list any of the numbers because the table should be present. Okay, one more example down here. We're going to do a secant graph. Okay, oh, I forgot an X in here. Okay, so same thing again. Let's go through the process. I'm going to, we can do the transformations here in a moment. I would just list them right now. I'll list them on another paper because I don't have room over here. So what transformations do we have? Well, a number out front means I have a vertical stretch by 2 because it's greater than 1. I'm going down 1. And then the stuff on the inside here. So again, we go off to the side over here. We can take the pi over 3x minus pi, set it equal to 0. Solve this. So in solving this, okay, move the pi, gives me pi over 3x equals pi. Then I'm going to divide by this number. And what I end up with, this all drops out, x equals 3. Okay? So what does that mean? Well, when I did this, this was my phase shift. So my phase shift is going to be 3. It is also going to be the first number in my table, 3. Okay? But it also represents right or left. Since it is positive, I'm going to the right, 3. The number that is in front of the X is B. That determines if I have any kind of horizontal stretches and shrinks. And we flip it over. Okay? And we have to determine, is this number bigger or less than 1? Okay? So this is 3 divided by 3.14. So the bottom number is bigger, so this number is less than 1. So then I have a horizontal shrink by 3 over pi. And so that's the transformations. Okay? So what's the period going to be? The period is secant, so it's 2 pi over b. B is that fraction right there, so it's 2 pi over 3. And when I flip this over and multiply, I end up with 6. Okay? So the next step is, on the parent function for secant, zeros first, then pi over 2. So if I come over here and I do the same one again, but I'm going to do it with not equal to 0, but equal to pi over 2. Add that. So there's going to be 1/2 plus 1, which is 3 pi over 2. Then I'm going to multiply both sides by that, the reciprocal. And what I end up with is 9 over 2. Okay? So that means the next number is 9 over 2. So then what is that difference? This is 9 over 2. This would be 6 over 2. So it's a difference of 3 over 2. So add 3 over 2 each and every time. So add 3 over 2. And so that's going to be 12 over 2, which is going to be 6. Okay, 12 over 2 plus that is going to be 15 over 2. And then looks like every other one. So this right here is probably going to be 18 over 2, which is 9. Okay, but then looking at it, okay, it's going by that. So if I back up at some point, I'm going to be at 0. So the next number over has to be 3 over 2. So my scale is going to be by 3 over 2 because that's what I'm counting by. Okay. So remember, we don't scale it by this. We scale it by the spacing in between because it has to be uniform starting at 0. So if this is 0, this could be 3 over 2. This would be then 3, 9 over 2, 6, 15 over 2, and then 9. Okay? And then we're going to back that up going this way in the negative sense. So this would be a negative 3 over 2, negative 3, negative 9 over 2, negative 6, negative 15 over 2, negative 9. Okay. So, again, you're going to want to know the parent table for secant. At 0 over 1, pi over 2s and 3 pi over 2s are going to be the undefineds. 1, negative 1, 1 kind of a thing. Remember, we're doing U's. Okay? So let's plug our numbers in, and we want to make sure we're, you can do it so you can confirm it. If I plug in a 3, that's going to be 0. The secant at 0 is 1. 1 times 2 is 2. 2 minus 1 is 1. If I plug in 9 pi over 2, this is going to be pi over 2. I'm sorry, if I plug in 9 over 2, this will be pi over 2. The secant of which is undefined. automatically makes this undefined. If I plug in 6, this in here is going to be pi. The secant at pi is -1. And -1 times 2 is -2. -2 minus 1, -3. This is going to be 3 pi over 2, which would be undefined. And if I plug in 9, this is going to become 2 pi, the secant of which is 1. 1 times 2 is 2. 2 minus 1 is 1. So there's my scale there. So this can be 1, 2, 3, -1, -2, -3. And then we go put in our dots. At 3, we have a 1. So remember, that's the bottom of the U, and it's going to go upwards from there. It's undefined here, so we put in our vertical asymptote. Should have done that first, sorry. Vertical asymptote, and then another one at 15 over 2. Okay? What this shows me is that the distance between the vertical asymptotes is that much. Okay? Which means if I go the same spacing over here, there's the next one. And I can just keep doing that and just put them all in right now. This is what I usually do. I put them all in, all equally spaced, and then it makes me able to draw my picture very easily. You are required to do a minimum of 2 periods. If you go more than that, that's fine. It's not a big deal. So at 6, we're at -3. 9 is back to 1. And so high, low, low, right in the middle. And then high, and then back low, right in the middle. So I know that my U shape is going down this way because they always go away from the x-axis. This is going this way. And I just do U shapes going away. That's all I'm doing. They're kind of flattish on the bottom. They're not like parabolas where they're kind of pointy. They're supposed to be kind of flattish. And that one, and that one. So that is 1 period. That's 2 periods. I don't need any more, but I have more. It's no big deal. Okay? If you wanted to, you can do this one over here. It would be like that. And then this is the other half over here. If you want to complete your entire from -9 to 9. Okay? So this is more than 2 periods. But this is fine. Okay? So the only thing left to do now is to identify the vertical asymptotes. And we can see clearly where's the first one that is non-zero at 3 over 2. And it is how far apart? This is 3 over 2. So add a 3 over 2. So basically it's 6 apart. Is that right? No, it'd be 6 over 2, which would be 3 apart. So then the first one is at 3 over 2. Okay, plus or minus. Okay, and then how far to the next one? The next one is over at 3. So I'm adding 3 each time, or minus 3 each time. There's no pi here because the pi got removed. So it'd be 3 over 2 plus or minus 3 in. A multiple of 3. Okay, and then there's your counter as n equals 0, 1, 2. So there's the vertical asymptotes, x equals, excuse me. And so that's how that graph is drawn. Okay, so the process is exactly the same every time, no matter what you have in here. Most of the time you won't have pi in both spots, and there will be a pi down here. But I wanted to show you one that you're not required to have pi in there. I don't want you to be locking your brain into thinking it has to be a pi. So it's what? The first one that's non-zero, and then how far until the next one. If I add 3 to this, I get that. 3 is the number you're adding or subtracting each time, and then it's a multiple of that. So there's the 2 graphs. We'll do more together in class. If you have any questions, make sure you ask.